In this video, we'll take a look at section 4.8, which is applications of polynomial equations and functions. Now, our first objective is solving quadratic and polynomial equations. Now, in order for us to solve quadratic and polynomial equations, we have to use one key property. It's called the principle of zero products. Now, what this states is for any real numbers a and b, if ab is equal to 0, then either a is equal to 0 or b is equal to 0, or both are equal to 0. So if you're multiplying two numbers and your result is 0, that means one of those numbers have to be 0, or both of them have to be 0. Now, strategy when we're solving polynomial equations: write the polynomial in standard form, which means set one side equal to 0. Then you're going to factor the non-zero side. And at step 3, set each factor equal to 0 and solve. Let's take a look at an example. So we have x squared plus 8 is equal to 6x. Well, our first step, let's get one side equal to 0. So let's subtract 6x from both sides. We get x squared minus 6x plus 8 is equal to 0. That's step 1. Step 2, we want to factor. So we have to go back to our factoring techniques. So we have a trinomial, and we don't have a number in front of our x squared. So we need two numbers that multiply to 8, positive 8, and add up to negative 6. So we could use negative 4 and negative 2. So we have x minus 4 times x minus 2. So that was step 2. Now step 3, we set each factor equal to 0. So if we take a look at our equation, x minus 4 times x minus 2 is equal to 0. In order for this to be true, one of these factors have to be 0, or they both have to be equal to 0. So what we do is we go ahead, take x minus 4, set that equal to 0, and then x minus 2, we set that equal to 0 as well. And now you solve each one of these equations. So for the first one, add 4 to both sides, we get x is equal to 4. Second equation, add 2 to both sides, we get x is equal to 2. So we get two solutions to this equation. Either one of these solutions, if you plug it back in, it'll give you a true statement. Let's take a look at another one. Solve. Okay, so we have 5y plus 2y squared is equal to 3. Okay, so we have 5y plus 2y squared is equal to 3. Now first, let's get one side equal to 0, so let's go ahead and subtract 3 from both sides. And now the left-hand side, let's write this into standard form, in descending order. So we want to write our highest exponents first, and then work our way down. So we have 2y squared plus 5y minus 3, and we have equal to 0. So it's in standard form, and now we have to try to factor it. Remember, first thing you always look for when you're factoring is a GCF. But if you take a look at all three of these terms, they don't have anything in common. And now we have a trinomial, and we have a number in front of our y squared. So we have to either use the AC method or the trial and error method. So my go-to is the trial and error method. Now I know when I multiply these first two terms, it has to give me 2y squared. So it has to be 2y and y. When I multiply my last two terms with each other, it has to give me negative 3. So when I multiply these last two, it has to be negative 3. So let's see if I could come up with the right combination. Let's try a minus 1 here and a plus 5 here. I'm sorry, plus 3 here. You have to check to see if you get the right middle term. So I'll multiply the inside, this gives me negative 1y. Multiply the outside, it gives me positive 6y. If I add them, I get 5y, which is that same middle term. So that means I factored it out correctly. Now let's go ahead and set each factor equal to 0 and then solve. So we have 2y minus 1 equals 0 and y plus 3 equals 0. Let's go ahead and solve each equation. So for the first one, let's go ahead and add 1 to both sides. We get 2y is equal to 1. And then go ahead and divide both sides by 2. We get y is equal to 1/2. Second one, let's go ahead and subtract 3 from both sides. We get y is equal to negative 3. And then we have finished this problem. So we get two solutions. We get y is equal to 1/2 and y is equal to negative 3. Let's take a look at another problem. we have 8b squared is equal to 16b. Let's get this into standard form. So subtract 16b from both sides. So we get one side equal to 0. So we have 8b squared minus 16b is equal to 0. And now let's go ahead and see if there's a GCF. So both these terms, they have an 8 as a factor. So they have 8 in common, and they also have a b in common. So we could factor out an 8b. And then we're left with b minus 2. Now we go ahead and set each factor equal to 0 and then solve. 8b, this is a factor. So we're going to go ahead and set that equal to 0. Then we have b minus 2, set that equal to 0 as well. And now we solve for b. So let's go ahead and divide both sides by 8. We get b is equal to 0. And then the second equation, add 2 to both sides. We get b is equal to 2. Let's take a look at another example. This one a little bit more difficult. This time we're not dealing with the quadratic since we have an x cubed. So we have x cubed plus x squared is equal to 6x. But let's go ahead and approach it the same way. Get one side equal to 0. So let's subtract 6x from both sides. We get x cubed plus x squared minus 6x is equal to 0. Now let's take a look at a GCF. Each one of these three terms have an x in common. So let's pull out that x. We're left with x squared plus x minus 6. And now inside the parentheses we have a trinomial. We could factor that out some more. So two numbers that multiply to -6 and add up to 1. We can use plus 3 and minus 2. Okay, so we have it completely factored. Let's go ahead and set each factor equal to 0 and then solve. So for the first equation, this is already solved. X is already by itself. So one of our solutions is x equals 0. Next equation, let's go ahead and subtract 3 from both sides. We get x is equal to -3. And then the last equation, let's go ahead and add 2 to both sides. We get x is equal to 2. So we have three solutions in this problem. We have x equals 0, x equals -3, and x equals 2. Let's take a look at another one. This one, the way that this is worded is a little bit different. It says given, so we have a function here, given that f of x is equal to 10x squared plus 13x, find all values of x for which f of x is equal to 3. Okay. So we want to figure out all the x values where f of x is equal to 3. Well, what we could do in this case, since we're trying to figure out all the x's for which f of x is equal to 3, let's go ahead and change f of x to a 3. Put this in black. So we have 3 is equal to 10x squared plus 13x. And now we have our quadratic equation that we need to solve. So we just had to set up the equation first, and now we go ahead and solve it. So solving it, very similar. Get one side equal to 0. So we have 0 is equal to 10x squared plus 13x minus 3. So we get 0 is equal to, now we have to factor this. So let's try to think of how we could factor this out. Okay, there is no GCF, so I can't factor out a GCF. And now what I'm going to do is, I'm going to try trial and error. So when I multiply these two terms together, it has to give me 10x squared. So I'm going to try 5x and 2x. When I multiply my last two terms, it has to give me -3. So let's go ahead and try out, let's do a -1 and a +3. Let's see if this gives us the right middle term. So this gives me -2x. The outsides gives me +15x. If I add them, I get that 13x that I have in the middle. Okay, so this is the correct factorization. Now we go ahead, set each factor equal to 0, and then solve it. So we have 5x minus 1 equals 0, and then 2x plus 3 is equal to 0. First equation, add 1 to both sides. You get 5x is equal to 1, and then go ahead, divide both sides by 5. you get x equals 1/5. Second equation, subtract 3 from both sides. You get 2x is equal to -3. And then divide both sides by 2. We get x is equal to, we get -3/2. So the x values where f of x is equal to 3 is x equals 1/5 and x is equal to -3/2. So we just had to set the equation up first, and then we went ahead and solved it using the same strategy. Now let's take a look at applications. So with applications, very similar. We have to set up our quadratic equation first, and then we could go ahead and solve the equation that we set up. So it says fireworks are typically launched from a mortar with an upward velocity of about 64 feet per second. The height h of t in feet of a weeping willow display t seconds after having been launched from an 80-foot high rooftop is given by h of t equal to -16t squared plus 64t plus 80. How long will it take the cardboard shell from the fireworks to reach the ground? Okay, so we're given this function h of t. This tells us the height of the cardboard shell after t seconds. So we have h of t is equal to -16t squared plus 64t plus 80. Now, in order for this cardboard shell to reach the ground, that means that our height has to be 0. So what we're going to do is plug in 0 for our height, and then solve the remaining equation. So we have 0 is equal to -16t squared plus 64t plus 80. Now let's go ahead and take a look if there's a GCF. Okay, so I have these three terms. We want to determine if there's a number that can go into all three of these. Okay, we want to find the largest number that can get into all of them. I believe 16 does go into all of them. So what we can do is factor out a 16. But now be careful, since our t squared is negative, let's factor out a -16 to fix that. So we have 0 is equal to -16 times, we have t squared minus 4t, and then plus 5. Continue to factor. Let's factor out that trinomial. We need two numbers that multiply to give us, I'm sorry, there should have been -5 right here. Two numbers that multiply to give us -5 and then add up to -4. So we can use t minus 5 and then t plus 1. Now go ahead and set each factor equal to 0. Now notice this -16. This is a factor, however, it doesn't have a t with it. Okay, so we don't have to set that equal to 0. So we just have the t minus 5 is equal to 0. And t plus 1 is equal to 0. Now if we solve for each one of these equations, we get t is equal to, we have 5, let's use our units here, 5 seconds. And we have t is equal to -1 second. Now, always make sure that your answers make sense with the context of the problem. Now, since we're dealing with time here, there's no way that time can be negative. So you have to get rid of that negative result, because you can't have a -1 second. Doesn't make any sense. So the time that's going to take for that cardboard shell to hit the ground is 5 seconds. Okay, so just be careful. Make sure that your answers make sense with the context of the problem. Let's take a look at another problem. Okay. We're given that an envelope is 4 centimeters longer than it is wide. Then it says the area is 96 square centimeters. Find the length and the width. Okay, so over here we have two unknowns. And now, okay, so we have length and width. Now what we used to do before, when we were in in chapter 3, I believe it was section 3.4 or 5, we used to let one of them be x and one of them be y. Now with these types of problems, since we're dealing with the area, what we want to do is write out a quadratic equation. We want to use the same variable. Okay. So since we're comparing the length to the width here, let's let our width be x. So we're going to let our width be x, and now since the length it's 4 centimeters longer, our length has to be x plus 4. Now envelopes, they're in the shape of a rectangle. Now the area of a rectangle we can use the formula, it's length times width. Now this formula is going to allow us to set up our equation. So area is equal to length times width. Well, this is telling us that the area of this envelope is 96 square centimeters. So we're going to have 96 is equal to, and now our length, which is x plus 4, times our width, which is x. And now this is the equation that we have to solve. So in order to solve this equation, we have to get into standard form. Let's go ahead and distribute out our x's. So we have 96 is equal to x squared plus 4x. And now we have to subtract 96 from both sides. Okay, so we have 0 is equal to, we have x squared plus 46 minus 90 plus 4x minus 96. And now let's go ahead and try to factor it. So we need two numbers that multiply to give us negative 96 and then add up to positive 4. Okay, so we're going to have to think about this one a little bit. What could we use? Now, whenever you come across this problem, it's a little bit difficult to see what these two factors are. Let's go ahead and use a factor tree, and I'm going to break down 96 completely. So first 96, I could break this down with 2 and 48. And then this 48, I could break this down with 2 and 24. 24, I could break down with 2 and 12. 12, I could break down with 2 and 6. And then 6 can break down to 2 and 3. The reason why I broke this down is now this allows me to see what numbers I can work with. So I have 2 times 2 times 2 times 2 times 2 times 3. Okay. So I need two numbers that multiply to give me negative 96, and I have to add up to 4. Okay, let's see what we can use here. So if I used these three 2's for one of my factors, this would be 8. I have to use the remaining for my other one, 2 times 2 times 3, which actually gives me 12. Okay. Now remember, one of these has to be negative, and then it has to add up to positive 4. Okay. So a combination I could use, let's say negative 8 and positive 12. Negative 8 times 12, that gives me negative 96. And negative 8 plus 12 gives me that positive 4. So that allowed me to figure out what my two factors were. So I have x minus 8 and x plus 12. Now go ahead, set each factor equal to 0. And then solve. So the first one I get x is equal to 8 centimeters. The other one I get x is equal to negative 12 centimeters. But remember, your answers have to make sense with the context of the problem. Since we're dealing with length here, there's no way that you ever measured anything and you got a negative 12 centimeters. Okay, it's just not possible. So this negative 12 centimeters, we have to get rid of that result. So we have x is equal to 8 centimeters. So our x, that represented the width. So width is 8 centimeters. And now since our length was 4 centimeters longer, that means our length has to be 12 centimeters. Okay. Let's take a look at another problem. With our next problem, we're going to take a look at the Pythagorean theorem. Pythagorean theorem has to do with right triangles. Right triangles are triangles that have an angle of 90 degrees. One of them has to have, one of the angles has to be 90 degrees. And that's what this little square means. It means that angle is 90 degrees. Now, whenever you have a right triangle, the Pythagorean theorem holds. And what this states is a squared plus b squared has to be equal to c squared. Now this a, this is considered a leg. This b is also a leg. And then the c, this is called the hypotenuse. Hypotenuse is the longest side of a triangle. So let's take a look at this example. So we're given that one leg of a right triangle has a length of 10 centimeters. Then the other sides have lengths that are consecutive even integers. Find these lengths. Okay. So let's go ahead and draw our triangle. So it's telling us that one of our legs is 10 centimeters. So let's let this leg be 10 centimeters. Then it says the lengths, the other sides have lengths that are consecutive even integers. So what that means is, say if one of them is 4, the other one has to be 6. So that's what it means by consecutive even integers. But we don't know what the first integer is. We're going to let that be x. But in order to get to the next even integer, you have to add 2 to it. Okay. And now since we know that the longest side is our hypotenuse, we know that this side has to be x plus 2, and then the bottom leg has to be x. And now we go ahead and use the Pythagorean theorem. So using the Pythagorean theorem, we have it's a squared plus b squared is equal to c squared. So we have 10 squared plus x squared has to be equal to x plus 2 squared. Now let's go ahead and solve this equation. So let's get rid of these second powers. So 10 raised to the second power gives me 100. X raised to the second power gives me x squared. I have equal to. Now for the right hand side, x plus 2 raised to the second power, remember this is x plus 2 times x plus 2. So you would go ahead and FOIL it out. You get x squared plus 4x plus 4. Now let's get one side equal to 0. So I'm moving everything from the left to the right. So I get 0 is equal to, now my x squareds cancel out. I get 0 is equal to 4x. And I have minus 96. So now we don't have an x squared here. I just have this linear equation. It's no longer a quadratic. So let's get my x's by themselves. So I have 96 is equal to 4x. And now I can go ahead and divide by 4. So I have x is equal to, so now 96 divided by 4, this is going to give me 24. So the sides of this triangle, we have 10. That was the side that was given to us. That was one of the legs. Then x represented the other leg. And then the hypotenuse, since it was x plus 2, this would have to be 26. Now let's take a look at one last problem. So it says, in order to build a deck at a right angle to her house, Monica places a stake in the ground a precise distance from the back wall of her house. This stake will combine with 2 marks on the house to form a right triangle. Now from a course in geometry, Monica remembers that there are 3 consecutive integers that can work as sides of a right triangle. Okay, find the measurements of that triangle. Okay, so let's say this is the back of Monica's house, the back wall of her house. And then it says this stake, so she places a stake in the ground a precise distance from the back wall. So let's say this is our stake. And then it says this stake will combine with 2 marks on the house to form a right triangle. Okay, so let's say we have this mark and this mark. Let me make that mark a little bit straighter since it's supposed to be a right triangle. Okay. So the stake combined with the 2 marks on the house, and now we have this right triangle. Now it says, from geometry, Monica remembers that there are 3 consecutive integers that can work as sides of the right triangle. Okay. So consecutive integers, that means one right after the other. So for example, 3, 4, 5. But we don't know what the first one is. So we'll let that one be x. Then the next integer has to be x plus 1. And then the third one has to be x plus 2. So when we label our triangle, let's say this one's x. This would have to be x plus 1. And then the longer side, the hypotenuse, has to be x plus 2. Now let's go ahead and use our Pythagorean theorem. So it's the legs, the sum of the legs squared has to be equal to the hypotenuse squared. So we have x squared plus x plus 1 squared. This has to be equal to x plus 2 squared. Now let's go ahead and raise each one of these to the second power. So x raised to the second power, I get x squared. I have plus. Now for that binomial, x plus 1 raised to the second power, remember this is x plus 1 times x plus 1. That leaves me with x squared plus 2x plus 1. I have equal to, and then the right hand side, we saw this in the previous problem, this is x squared plus 4x plus 4. Now let's go ahead and solve this equation. First, I notice that there's some like terms I can combine. X squared and x squared, that's going to give me 2x squared. I have plus 2x plus 1 is equal to x squared plus 4x plus 4. Now let's move everything to one side, so we have one side is equal to 0. I'm going to move everything from the right, I'm going to move it to the left. So I subtracted x squared, I'm subtracting 4x, and I'm subtracting 4. So 2x squared minus x squared, that gives me x squared. 2x minus 4x, I get negative 2x. 1 negative 4 gives me negative 3. Now let's go ahead and factor. So you have x minus 3 times x plus 1. Okay, so I needed 2 numbers that multiply to give me negative 3 and then add up to negative 2. So I could use negative 3 and positive 1. Now set each factor equal to 0 and then solve. So we have x minus 3 is equal to 0, and then x plus 1 is equal to 0. So for the first equation, go ahead and add 3 to both sides. We get x is equal to 3. And then the other one, go ahead and subtract 1. You get x is equal to negative 1. But remember, over here we're talking about distance. Okay. Now distance cannot be negative. So this x equals negative 1 we have to get rid of. So the sides of this triangle, the first side has to be 3. The other side has to be 4. And then the hypotenuse has to be 5. So that was it for this section. Remember, if you have any questions, please email me.